To the online poll for extra credit attendance. It should. Yeah, it looks like it's working. Okay. Have you guys all set up your GitHub accounts? Have you? So it looks like 25 of you have set up forks, which is good. I'm going to be posting all of my kind of notebooks and class notes and stuff to the GitHub repository. I will not be posting any of these kinds of files onto CCLE with very rare exception. Okay, so if you want the notebooks and stuff from class, and if you want to kind of see those and whatnot, you're gonna want to set up a repository that is either a clone of mine or a fork. Okay, if you clone mine, then it's because you do not have write access to my repository. It will be a one-way. It'll be a one-way feed. Okay, I'll update my repository, and then on your machine, you'll just kind of pull those changes. You'll do a git pull, and it will download all the changes to that I've made to my repository. Okay, but you will not be allowed to, if you make any kind of changes to those files and you commit them to your repository, then it will create conflicts. Okay, so that's fine. You can just kind of receive them and open them and look at them. But again, if you try to commit a change to your repository, because it's a clone of mine, it's going to create some kind of conflict. If you want the ability to make changes to your files, but also at the same time download kind of updates as I go along, I'm going to be adding more files. If you want that ability, then you're going to have to create a fork. Okay, and you do this by, while logged into the GitHub website, you'll click fork, okay, and it will create a fork on your account. And then while you have your fork set up, you will clone your fork. So let me just kind of, maybe I'll see if I can draw a diagram of what I'm talking about here. What is this? Okay, so we'll say this is kind of my repository, and you create a fork into your account. Okay, and then you will clone to your local PC. Or local machine. Okay, and so this is going to be right, and then and what you'll have is, if you check git remote -v, you'll see kind of an origin, and so this is the origin. Kind of, you'll have origin, probably branch master, whatnot, and basically, you make changes on your local machine, and you will synchronize, push those changes onto back to the origin, right? So you'll have push and also kind of pull, push and pull, right? But as I make changes, I'll make changes, and you want to be able to download those. So that's going to require you to also set up, this is called an upstream. okay? And so what you'll do is you'll fetch get fetch upstream, all right, and then you'll merge them into your local branch. Get fetch upstream and then get merge upstream master. Okay, and so so I'll make changes to my repository up, up there, and then you'll fetch those changes, merge them into your local thing, and then once everything's merged properly, then you'll push those to your repository. Okay, I've recorded a couple videos kind of just demonstrating this. Under week 1, there's a video on kind of configuring the forked repository to fetch the upstreams, and it's just really just git remote add upstream, okay, to configure a second remote repository. So your local repository is set up to synchronize with your origin, okay, and so you can do git push and git pull from your origin by default, and that will synchronize your GitHub account to your local repository, and that will be in sync. Okay, but if you want my changes, which are in the upstream, you've got to set up a remote upstream repository, and you can fetch those changes, merge them into your local one, and then push those back to your own remote repository. Okay, so these 2 videos kind of show that, and to kind of demonstrate that, I'm using a different computer under my other account, the Redshirt Prof account. Okay. See. Okay, so that's what we have, and then again, everything is going to be posted onto the class repository and not CCLE. So this link will be set up. Okay. All right. Also, don't forget. So this week, on Wednesday, the Introduction to Python course will be due. Okay. It's a few chapters in there, so complete that course, and I'll add another assignment. It'll probably be the intermediate Python, and I'm trying to figure out which assignments I want to which courses from Data Camp I want to assign. I like a lot of them, but the complaint I got last quarter was I assigned too many of them. So we'll figure this out. Okay. All right, so today I thought we'd talk about some of the data structures, just some, Python syntax and data structures, primarily the list, and so this is the Jupyter notebook that I have set up here, okay? So we talked about in Jupyter you can add cells. They can be either markdown or code cells and things like that. And so here's my my first cell, and if you want a comment, you put a little hash mark and it's not going to run. So if I hit Shift Enter, it ran, and we can see that it ran because it says in1. Okay, the cells that haven't been run, the in is blank. Okay, so this one has run and it does nothing. Okay, and then as we move along, just kind of, this is a lot of this stuff is similar to R, a little bit different, but basically a new line will signify the end of a statement. Okay, you don't need to put in a semicolon or something to indicate the end of a statement. Just a new line will do that. And so here I've got x equals 5. That's one full statement, and then I say print x, and when I run that, it does that, right? It assigns 5 to the name x, and then it prints out x, and it shows 5 onto the screen. Okay. If you want multiple commands on the same line, you can use a semicolon. Okay, so here we're going to assign 6 to y and 7 to z, and then we're going to add y and z together and print the result out, and we get 13. This is no surprise here. if you've got some kind of long statement and you want to break it up over multiple lines, you can put in a backslash, and a backslash will tell Python the statement is continued on to the next line. So so here I've got A is, we're going to take the values 1, 2, 3, 4, 5, add them together and assign that to A, and it's going to print out 15. If I don't have this continuation mark, okay, it throws an error, okay, because it says it's going to assign 1, 2, 3 and see this as the end of the statement and assign the value 6 to A, and then it sees a +4, +5, and it doesn't know what to do, okay? So, so if you've got something continued on more than one line, you need to put in that backslash, okay? Or if you have an opening parentheses, then Python knows to search for the closing parentheses to kind of complete the statement. So here, I don't have the backslash, but I have an opening and a closing parentheses, okay? And again, if I remove one of these parentheses, we get an error, okay? Or over here, if I leave off this parentheses, it also gives me an error because it's expecting the end of the line. Same thing with square brackets. Square brackets are how we indicate to Python that we are creating a list, okay? If we're creating a list, we use square brackets, and a list in Python is kind of like a list in R in that you can mix data types. You can have characters and integers and different, Boolean values, and mix those up together and form a list, okay? And the square bracket, opening square bracket says we're starting a list. Closing square bracket means I've finished defining the list. And so again, this works. If you leave this off, it throws an error, okay? Okay, that's simple enough, right? Oh, okay, so here's an important thing to get used to, in that Python does not use curly braces. So when you coded in R, you'd have like an if statement, and then to kind of bunch all of the commands that get run if the if statement is true or whatever, or if you have a for loop or whatever, you have a curly brace to start it. Everything in between the opening and closing curly braces are treated together, right? You define a function, and if it's more than one line, you have an opening curly brace and a closing curly brace to kind of group all those lines together. In Python, there's no curly brace. Instead, you have a colon, and then you use indentation, right? And all the lines that are indented belong to the if statement or whatever statement that has the colon, okay? So in IPython, as you type stuff out, as soon as you type in a colon and you hit enter, it's automatically going to indent, okay? And it's going to keep, every line you write after that will be indented until you hit backspace to kind of bring it back to the the first position, and that indicates the end of the code lines that are bunched together, okay? And so this kind of forces nice formatting in your code to make it kind of readable. So, because in R, once you put everything inside a curly brace, there's no requirement to have your lines indented, okay? It's kind of it's good practice to indent your code so you can kind of see which lines belong to which code chunk, but it's not required. And if you wanted to just left align everything against the first column, it's not wrong and it will run. Python will not allow you to do that. You have to indent because indents are how Python knows whether the line of code belongs to kind of the if statement or the for loop or whatever it might be. Okay, so I guess we'll cover if statements a little bit more later, but here I've got, I assign 8 to x, and I ask if x is greater than 5, which is true, then run print x is greater than 5 and print x itself. Okay, and then after that, it says print hello. Okay, I execute the exact same code chunk for x is 8 and x is 4, and so in this case, when x is 8, it's going to print x is greater than 5, it's going to print out 8, and it's going to print hello. Okay, so it says x is greater than 5, 8, and hello. Over here, with x equal to 4, this is false. Is x greater than 5? That is false, so it will not print x is greater than 5. It will not print x, but it will print hello. Okay, so when I run this, it prints hello. Okay, what will this code chunk do? Or this cell print out? Yeah, so here x is 4. This if statement is false, so it will not print x is greater than 5. But here where it says print x, okay, because it's not indented, this is going to run no matter what. Okay, so these two things, as far as the characters go, they're almost the same. It's just this one is indented, so this statement belongs to the if statement. Over here, because it's not indented, it does not belong to the if statement, and it will run regardless of the condition. Right, and so here we get 4 and we get hello. All right, and so this is something to be very aware of, and there's no I want to say the minimum number of spaces that are required when you tab is 2. I want to say I think IPython by default will indent 4 characters, but and the levels of indents are important. Okay, you can't if I try to do this, okay, it throws an error. Okay, it says here's this statement is indented 1 and it belongs to this. This statement is further indented, but I don't know why it's indented, because you only indent code if there's like some kind of statement for that code, that line to belong to. So this is going to throw an error. Okay, you can't just arbitrary indent. If I do this, this is also going to throw an error because this is like indented at a different level. Okay, and it doesn't like that. Okay, if I let's see, this will work. Okay, I don't know why it's red here. But this works, okay, because they are indented at the same level, so it's okay. It's okay with that, right? And I think 2 is the minimum. I don't think 1 will work. Let's see. Oh, maybe single spaced indent is. Oh, okay. I guess you can just do 1 space, and that counts as an indent. Okay. But by default, I think it's 4 characters, 4 spaces. Okay, and that's fine. And you know, I don't know if you want to get in an argument over tabs versus spaces, but I think it when you hit tab, it actually inserts 4 spaces. So, okay. So in backspace. So you know, these are just nice little features of this. So you know, just be careful about the indenting. It's something to get used to, but once you get accustomed to it, you end up appreciating it a lot because it makes your code a lot more readable because it will always have the proper indents. Otherwise, it won't run. Okay, and so you can easily identify kind of what belongs to which statements. Okay, now we can start talking about data types. We've got a few different data types. Things probably that we're used to, integers and floating point numbers, okay? These are called integers and they're called floats. In R we call them double. But in Python, we have floats, and there's technically a whole bunch of names for the floating points. You can have floating point single precision and floating point double precision and things like that. By default, it's going to be floating point double precision, so equivalent to what R uses by default. But if for whatever reason you wanted to like save the amount of memory that gets used by your code, you can specify different things here. Okay, we got strings, booleans, and complex numbers. Okay, just like R. All right, so here's one thing that I really appreciate about Python. Okay, is that if you just type in the number 3, it's going to treat it as an integer. Okay, and if you want it to be a floating point number, you can't just type in 3. You type in 3 point. Okay. You don't have to do 3.0, but you have to at least do 3 point, okay? And that will indicate that it's a floating point number, right? So if I say A is 10 and I ask what is its type, it's going to be an integer. If I say B is 2 and I ask what is its type, that's going to be an integer, okay? And if I do C is equal to 10 divided by 2, okay, integer type 10, integer type 2, integer 10, integer 2. Division, however, will always result in a float, okay? So C is going to be 10 divided by 2, and we'll ask it to print C and tell us its type, okay? And we see that when we do 10 divided by 2, it returns 5.0 to kind of distinguish it from the fact that it's not integer 5, but it's floating point 5, okay? Whereas over here, okay, A is integer 10 and B is integer 2, and if I do 10 times 2, integer times integer, and I assign that to D, okay, it gives me back 20, and that will say it's an integer. Whereas over here, if I say just 5 point, this point here indicates that it's a float. Now if I do 5 point times 2, and I assign that to E, then this will become 10 point, or 10.0, and that will be a float, okay? So integers times integers will result in integers when you multiply. And a floating point times an integer will be floating point, okay, as we would expect. But division will always return a floating point number, unless you purposely use integer division, which I can do here. Okay, and so A divided by B, this is the double slash will be integer division, okay? But if you do something like 10 over 3, or even like 11 over 3, okay, it gives you just back the integer portion, whereas this will give you a floating point number, right? Okay. So the double slash, this is the integer division. It's the same as, I don't know, back in elementary school when you learned division with remainders and you said 11 divided by 3 and your answer was 3, remainder 2. It's just that the whole number part, okay? Okay, so that's that. Integers are variable precision, so you can do monstrous calculations without running into kind of overflow errors. So if I tried to do this, 2 to the 1023, so star is the same as raising to a power. So let me just kind of open this up over here in R. Okay, so I can do 2 raised to the 1023, and I get, I think this is getting close to integer max, 2 2 to the 1024 breaks down, okay? This is, this is actually, because this surpasses double max on R. In Python, we can do this. I can say 2 to the 1023, that works. 2 to the 1024 works. These are just really big numbers, okay? All right, but, and that's because this is type integer, whereas floating point uses 64 bits of floating point precision, and so it's limited, right? It's limited by the machine machine maximum, okay? So this is exactly what we get in R, and then when we try to do this 2.0, which is raised to the 1024, this is going to produce infinity, right? I'm sorry, it's going to not produce infinity, it's going to produce an overflow error, okay? Result too large. Okay, and then again, you know, floating point precision is implemented at the computer level, okay, the machine chipset level, and I think everyone's machine uses an Intel chipset. I don't know, I'm trying to think what commercially available computers don't use Intel chips now. I guess AMD now has a few like Ryzen machines, and maybe Chromebooks don't, but I think they all follow the IEEE standard. So anyway, we have the same issue of 0.1 plus 0.2. We can ask, is that equal to 0.3, right? So 0.1 plus 0.2, we're going to assign that to S, and we ask, is S equal to 0.3, and that's going to return false, right? So here's 0.1, here's 0.2. 0.1 and 0.2 added together is 0.3 something, okay, which is not equal to 0.3. So that's you know, just like before, you just have to watch out for issues with floating point precision. Okay, trues and falses in R we call them logical values. Over here we call them bools or booleans. And this I always have to get used to as well. True is spelled capital T, lowercase R-U-E, okay? If you use all caps true, which is where you have to type into R, it's going to, it's not going to recognize what that is, okay? So you have to use capital T, lowercase R-U-E, or capital F, lowercase A-L-S-E, okay? All right, so true or true will not be recognized if you don't capitalize it correctly. Okay, so type true is a Boolean, and that's that. Okay, so no biggie there. And then anything that you enclose in quotes, whether it's single quotes or double quotes, single or double quotes are fine. Okay, so you can have type hello, we can have type hello, and type, and I can also just, you know, say print your, or and that will work. And if you want the opposite, you can do this. Oh no, you have to escape. Okay. Escape the quote if you want to include a literal quote. Okay, so these are all, whether you use single or double quote marks, it's fine. If you're using double quote marks, you can obviously include the single quote mark, no problem. If you're using single quote marks, you got to escape it. All right. Okay, and then lastly, we have none, type none, okay? And this is kind of like the null object, okay? Except it's the none type. So if we ask, what is type none? It's capital N, lowercase o-n-e. This is the none type, okay? we can check if n is, we can assign none to n, okay? And if you want to check to see if it's none, okay, you have to say, is n none? N is none, that's true, okay? N equal to none will also return true, but this is not what this is not the recommended method. Okay, the is none is the recommended method, and there's a full explanation at this Stack Overflow. But anyway, this is what you should use. Okay, and then we've got you know, if n is true, print hello, so it's not going to do anything. Okay, but you can do if n is none, then that will work. Okay. All right, we have so those are the kind of the data types, and then the data structure. Kind of, we will start with lists, and there's a lot to say about lists in Python, so we'll talk about this. Okay, this is probably lists. There's a few data structures in Python that are really important, and lists is probably one of the most important ones. And then later on we'll cover NumPy, which uses arrays, and those are also important. But here is a list, and a list can contain mixed data types. Okay, and you can also nest lists inside other lists. So here I've got a list called fam, and we've got string values mixed in with floating point numbers, okay? And so here I'm just going to assign this list to that, and here I've got a list of lists, okay, where each list inside has 2 elements in it, and the entire list of 4 lists of 2 go inside fam2, okay? And so you can ask, you know, what is it? You can have it kind of output that, and this is what the list looks like. And fam2, it looks like that. Okay, so this is what lists look like, and we use single square brackets to define a list. All right, and then nesting a list inside a list is no problem. Okay. All right. Python uses zero indexing, and again, this is just something you gotta get used to. Part of you will resist this, but this is what we do. Okay, so we can ask, what is the zeroth? What is the item at the 0 index? Okay, so here it starts off at 0 index, which is basically the first element. Okay, and so this is going to return back the string Liz. Okay, that's the first item at the 0 position. Okay, what will fam2 0? What's at the 0 position in fam2? It's the list that says Liz 1.73, right? That's the item at the 0 position in fam2. It's the list at Liz in 1.73. Okay, so here you could say 0, 0, and that's going to give us the 0 index element of fam2 0, which will just be the string Liz. Okay. If you use negative numbers, then that will count from the end. Okay, so -1. So this is -1, and that's going to be 1.89. Okay, it doesn't start off at -0. Okay, because 0 is here. -0 is still 0. Okay, so -1 is going to be 1.89. Okay, like if I tried -0, it's going to just see that as 0. Okay, and give you back Liz. So -1 gives you the last element. Okay, and you know, -2 will give you the second from the last element, which will be dad in this case. Okay, So we've got -1, and then for fam2, because it's a list of lists, it's going to give you the last list here, and then you can do -1, -1, and that will give you 1.89. Okay. Here, if you want to select something within the list, you can use list slicing, much like this, okay? The slices happen basically at the comma locations, okay? So you can say fam1:3, and it basically slices at the first comma and ends at the third comma. So 1:3 will pull out 1.73 and Emma, okay? So we're going from slicing at the first comma and ending at the third comma. Okay. If I did 1:2, this will only pull out from the first comma to the second comma. And if I did 1:1, this pulls out nothing, because you're basically slicing from the first comma to the first comma. So you can think of the slice happening at the commas, and there you go. And so you can also do. I'll show you. Okay, so I guess there's. These are the other examples. Okay, fam2, which is this thing. I'm cutting from 0 to 2, so it's going to give me back this list and this list. Okay, or if I just do fam 0, 2, it's you can imagine a comma at the 0 and a comma and the second comma. All right, and if you want the if I want to get, let's say if I want to extract dad, where would I cut from? I would say 6 to 9, right? 6 to 8 will pull out, I'm sorry, 6 to 8, not 8, not 9. 6 to 7 will pull out dad, and 6 to 8 will pull that out. Okay, if you leave off what comes after the colon or what comes before the colon, it will do everything after the second comma or everything up to the fourth position. So here, everything after the second is Emma and everything on, and everything up to the fourth will give you up to 1.68. If you just put a colon here with nothing, this will create a copy, what's known as a shallow copy of the entire list. Whereas if you did this, it complains. Okay, so you can't just leave it blank, right? So if you want, so this works. This throws error. Right, so here, what will this return? So you're counting backwards. 1, 2, 3, 4, 5 to 1, 2. So 1.68 to 1.71. Okay. All right. In R, you can kind of get disjointed elements. Like you can ask for the first, third, and seventh element. We don't have a simple solution. You can use something called a list comprehension, where here we have the list A and then the list of elements B, and we would say I want A sub I for I and B. And you have to do this. It's technically running like a tiny little loop that says for I and B, take this element and throw it into a list, and this will pull out item at index 1, index 3, and index 5. All right. Okay. Probably run out of time soon. here's an important distinction between Python and R is that your objects in Python, well, some of the objects in Python are what we call mutable. Mutable means that calling a function on the object will actually change the object itself. Okay? In R, that was never the case. In R, you call a function on a data frame and it will produce the results, but the original data frame is always untouched, right? And if you wanted to change the original data frame, you had to like assign the result of the function back to the whatever object that you wanted, right? So if you have like, you know, your data frame and then you say like, you know, sort it or something, it will return back the sorted data frame, but you'd have to store that as a copy or overwrite, you know, the original object. Over here, we have lists and we call, they are mutable. And so calling a thing on the list actually changes the list, okay? And to kind of get reference, so you'll have kind of the weird things where if you have two things referencing the same object in memory, both of the names are affected here, okay? So here I've got our list of the family members, okay? And then and here I'm going to assign this list fam to another thing called second, okay? And we're going to just change the 0th index element, Liz, to sister in second, okay? And what I'm going to ask is I'm going to ask it to print out second, and what we'll see is this list, but Liz has been replaced with second, okay? And when we print out fam, we're also going to see that fam itself has been changed, okay? Because they're both referencing the same object in memory, okay? So when we run this, it prints out fam originally. We change the 0 index item to sister, and it changes both, because they're pointing to both the same object in memory. Printing second and printing fam looks exactly the same, okay? If we don't want that, we have to create a copy, okay? So here, I can create a copy by doing second equals fam, okay? Using this. So this will shorthand create a copy of the list, okay? You can also just do fam.copy parentheses, and that will also create a copy of the list, okay? And then and here I do the same operation where I change the 0 index item in second equal to sister. The second list, I change that to sister, and then we ask it to print out second, and we print out fam, and we will see that fam is unchanged because we only modified the copy. So here we have the original list. The second list has been modified, and the original list remains unchanged because the second list is a copy. All right, and then same thing over here. You can use the fam.copy rather than using fam bracket colon bracket. Okay, those are basically just equivalent operations. Okay, and here I'm just changing this element from 1.73 to 1.65, and it has the same behavior as we had up here. Okay. If you you can also use list slicing in conjunction with assignment. Okay, and so if I print fam, it's going to look like this, and if I say print fam 1:3, replace it with 1.8 and Jenny, it's going to replace this element and this element with 1.8 and Jenny. All right, and so there we have that. So you can use the assignment in conjunction with the slicing. All right, we've got copy, which we've already seen, and now we have append. Okay, so here is the list fam, and I'm going to append the string me, okay, and this will actually modify the list itself, okay, And when you call append, you won't actually, it doesn't look like it has done anything. And it's only until you ask it to print out fam that you realize that it has actually modified the thing, okay? So calling fam.append will actually modify the list fam itself. And then when we call it, it looks like this. Append will just take whatever you give it, and it will just tack it on to the end of the list. You can also just use the shorthand of saying, here's a list, and plus, and you provided another list, and it's going to kind of combine them together. It's going to just append one to the other. Okay. However, this operation of doing fam plus another list doesn't modify fam itself, okay? And so if you wanted to save that, you need to, kind of, quote, capture that output and assign it back to fam. All right. So append will directly modify the list, and you can kind of extend the list in the same way using the plus operator, but you need to save that. You need to capture that change. And that's what we have here. Is that okay? You can insert an item into a given position, all right? But you can only, so you have list.insert, and it's gonna, you're inserting it at, at position 4, okay? So here, if we do this, so here is, 0, 1, 2, 3, 4, okay? It's gonna go in right there, before mom. You can basically think of it as inserting it into kind of the comma position, okay? And so that's what insert does. With insert, you're only allowed to insert one element, okay? So if you want to insert multiple things, say like you want to insert Joe and 2.0, that's not going to work, okay? I mean, it'll work, but it probably won't do what you're expecting. You're going to see, Liz 1.73, Emma 1.68, and then a list of Joe and 2.0 inside there like this, okay? So this is probably not what you wanted when you use insert. So insert only allows you to put in one thing, and it puts in that whole entire thing, okay? So here, if we tried to insert Joe and the value 2.0, it gives me back an error, okay? It says insert takes exactly 2 arguments, the position and the object that we want to insert, and it says you gave me 3, so I don't know what to do. So it complains. All right. If you want to kind of extend the list by this, you can use extend, okay, and that's going to tack on Joe and 2.0 at the end. And so this works, okay? And if you want to insert something like the elements Joe and 2.0 into the list, but at position 4, you can go back and you can use the slice and assignment together, and you can say, I want to assign Joe and 2.0 into basically this slice 4:4 here, okay? And that works. All right, so these are kind of some things that we can do. Oh man, all right. Okay, I guess I'll have to cover the shallow versus deep copy and all of that stuff. I'll save that for Wednesday here. Okay. Please do get your GitHub repositories set up so you can kind of keep up to date with the notebooks that I post up there.